Hey guys, it's a bit of a rainy, miserable day here, and so I've been chopping off some gold fingers from RAM modules to run a batch of fingers through, and I thought it would be worthwhile spending a bit of time doing a video about the different types of gold plating and why you have to be super careful when you're paying for the waste that you're processing to recover the gold. So we all know that you've got gold fingers like you do here on RAM and PCI cards and things like that, and it's called hard gold plating, and it's fairly easy to look up the thickness of the plating, and then by knowing the surface area of plated material you have a good idea of how much gold you're going to be getting out of fingers like that. The risk comes with stuff like this. Now, I'm not sure about what you guys do, but I tend to have to pay for most of my e-waste, and so when you see something like this for sale, your initial thought would be that those are going to be gold-plated fingers, and you will have some rough idea based on the weight of these, like the cut fingers, what your gold recovery is going to be. And the next level down essentially are boards like these, so this is a blank board, but you see them quite often in things like laptop trackpads where you see lots of gold plating, and to someone who doesn't understand the difference, they might confuse gold plating like this with gold plating like that. In fact, this board, I know for a fact, is a coating called ENIG, so it's electroless nickel immersion gold. The gold plating on boards like this and laptop trackpads and the body, for instance, of RAM, so this stuff here, is much thinner than the gold plating you normally have on your fingers. The reason I said to be careful of stuff like this is I know for a fact also that the gold plating on this one is ENIG, so once again I think it's about a 5 micro-inch plating of gold, a very thin plating, and when you're basically paying for the weight of the fiberglass, that can mean the difference between a profit or a loss, or like a small profit or a substantial loss if you bought a lot of this stuff when you think you're buying this stuff here. So the question that is going to come up is, how would you know the difference between ENIG and hard gold plating? Now obviously the function of the card or the function of the thing you're processing would be a very good indication to you. If the gold plating is generally just there to protect the pads until you solder to them, then it's very likely to be ENIG. If the gold plating is part of a mechanical connection where it has to deal with repetitive in and out sliding motion and scraping motion, then it's usually pretty safe that it is a hard gold plating. So to show you the difference between the two, the easiest way really for me is going to be to use some nitric acid. So what I have here is I've taken 1 milliliter of 70% nitric acid and I've mixed it with 1 milliliter of distilled water. So you've essentially got 35% nitric acid. And we know that nitric acid diluted in this way reacts very nicely with copper. So what I'm going to do is to show you the difference. So what I'll do is I'll put a drop of nitric acid on a finger from RAM. I'll put a drop of nitric acid on each of these two, which I know to be ENIG, electroless nickel immersion gold. And I'll also put a drop of acid on this. This is one of those flex connectors, probably out of a CD-ROM or something like that. And I have no idea what the actual gold plating thickness of this is. So by looking at the difference in how those three react, we should be able to tell fairly easily what the thickness of gold plating on these things is like. So I'll just set up all of this under the microscope, and yeah, let's have a look how it goes. Okay guys, so sorry about the change in sound. I've moved from the camera to wearing a headset while I'm working on the microphone, the microscope, and there's a little bit of wind outside as well, so it might be a little bit, it might be not quite as clear as on the camera. Okay, so as you can see, what I've done here is at the top I've got a set of fingers cut from a PCI card and a bit of fingers cut from RAM. And I suspect that both of those are going to be hard gold plated. Then in the second row in the middle of the screen here on the left, I have a board. I've got some solder terminals from a board that I know to be ENIG, so electroless nickel immersion gold, very thin plating. And I have some fingers here from a card that I also am relatively sure are going to be ENIG. The sample down the bottom here, I am interested in knowing what they use on these, so I really have no idea at this point. We will find out together. So what I'll do now is I will introduce a drop of 35% nitric acid onto each one of these samples, and we will hopefully be able to see together, it might take a little while, the difference in the reaction. Okay, so I'm going to drop there. A little bit of a drop, we'll give it a bit more there. Okay, drop on that one. Drop on this one. And a drop on the sample we want to know. Okay. Just to push things back into place a little bit here for the on the screen. And at first, so interestingly enough, if we look at the sample on the bottom, let me just get myself sorted here, and we'll do a bit of zooming in for you guys there. Sample on the bottom, the one which I was interested in knowing whether it was going to be ENIG or, oops, let me just see if I can get that for you guys. I might have to do a bit of, I might have to move my microscope up a little bit. Sorry, we're going to go out of focus a little bit here for a bit. So when I zoom in on that one, I should be able to move that into focus then. And what you guys will see is a fairly vigorous reaction. So the gold plating on that particular sample is pretty much 100% non-existent. That is a gold plating that would not be worth paying any money for the waste for. So you'll see by comparison to some of the other ones we have. So let's have a bit of a closer look at these ones. You will see the ENIG, electroless nickel immersion gold, thin plating over here. Once again, a fairly vigorous reaction, and as you will see, the bubbles they're going through the actual gold plating. And what will actually happen later on is once it's eaten away a little bit of the copper underneath, I'll show you how the gold plating essentially turns into powder on that one. This one here, surprisingly not that much reaction overall. So you can see where the actual fingers have been inserted into a card, and you can actually see if we look at, let me just grab something to point with. If you look at around the middle right hand side of the fingers, you can actually see where they have been inserted, and that's where the gold has been rubbed off, and that's why the reaction there is the most vigorous. Now if we compare the two samples we've just looked at, two samples of what we believe is hard gold plating, see a little bit of a reaction on the, oops, get this zoomed out for you, a little bit of a reaction on this PCI card on the left on the screen here. Still nothing like what we see down here for the pure ENIG. So in my estimation, the two on the left there are pretty much completely worthless. The one on the right here, which I know also to be not hard gold plated, but obviously there's a little bit more plating there than the ones on the left. Let me just oops, get this into focus for you guys. You'll see the same porousness of the gold is starting to show up there, where it's actually starting to react through the gold layer with what's underneath. But if we look at the actual ram finger, even though it has obviously, you can see the sliding marks on it, where it's obviously been inserted into a socket and pulled back out again, no noticeable reaction at this point. Let's go back to the PCI finger. So the PCI finger, obviously the gold coating is going to be somewhere in the middle. It's not quite as bad as the ENIG, which we can clearly see there, but it is definitely not performing as well as the very hard gold plating that's on that RAM module. So this might be a rough indication that even hard gold plating, there will be some difference. You might be inclined to think that there is a difference in color because the one on the PCI card does look a little bit different from the RAM, but I would say that it would be very hard to judge it by color, because if you actually look at the difference between those two, where we know one is quite thin and we know the other one is quite thick, there's not that much of a color difference really that I can tell in those two. Let's see how this one down the bottom goes. Yeah, that's definitely a very good reaction. So these type of flex connectors, even though they look quite golden, it might not look that golden on the actual camera at the moment, but the fingers on that flex connector do look quite golden. Clearly there is very little gold there. It's really only to protect it for one-time use. Same with the circuit board here. You can clearly see how porous the gold is, so porous on that the reaction is kind of happening through the gold. Same with these fingers here. I've tried at maximum zoom, but even at maximum zoom, looking at the hard gold plating on a RAM finger, very like nothing happening there. Up the top, where the plating is obviously not as thick, you can see there's a little bit of bubbling happening where it's touching the copper underneath the solder mask, but this is very good quality coating here. There will be this stuff here will come off as foils, not as dust. This here, the PCI one, is definitely not looking as good. Still better than, and it looks like, if you're looking at this, like it might actually come off as a foil. I might try and grab might be a good time to now grab just have a little bit of a scrape over, just see if I can have a little bit of a scrape over it to see if the gold, yes, you can actually see the gold is scraping off. So I suspect the gold from these will still, if you're processing them, come off as foils, but they'll be very thin foils by comparison to what we would get from the RAM finger on that side. I'll have a bit of a scrape on this one. Let me just fold this down gently, have a scrape, and once again, can I scrape through that? No, not quite. So the coating is quite thin, but it's not quite scraping off yet, I suspect. Let's see what this one here will do at the moment. No, not scraping off, just basically getting rid of the bubbles. And this one here, where we've gone quite green, yeah, so this is already scraping off, so there's bugger all gold coating. You can actually see the little flakes of gold floating in the nitric acid there. So I think what's probably worth doing right now is I'll leave this reaction with these ones here running for 15 minutes or so, and then I'll come back and we'll have a look at all of these. Let's get this into focus. We'll have a look at all of these 5 again and see how they've gone. So I'll be back soon. Okay, so about 15 minutes or so have passed, and hopefully the time lapse showed something. Now if we zoom in a little bit, get our focus done, you'll see that what appeared to be the finished plating has pretty much completely disintegrated. The gold from this, that, and that is likely to end up basically as dust when you're trying to recover it rather than coming off as nice foils. Now, nothing wrong with recovering dust. You just have to understand in terms of the price that you pay for it, whether it's worthwhile for the gold that you're going to get. So, and then by comparison, the thin hard gold plating you see there, interestingly, you can actually see the bubbles happening underneath the gold foil. So I believe you'll get that as a solid gold foil. Solid being a very relative term in this case. But here, as you can see on the RAM, a fantastic quality gold plating. Really very little reaction whatsoever, almost non-existent. So very interesting. So let's zoom out a bit, get the focus in, and let's have a bit of a scratch test. So over here, get the focus right. Over here, nothing much is going to surprise us. I think if I use the plastic tip of the pipette, yeah, it's pretty much what we expect. It's little fine particles of gold. Basically, the nitric acid has eaten the copper underneath, but the gold is so fine that it can't really stay as a foil. So yeah, I didn't know what the thickness of the plating on these were. The answer is almost non-existent. Just as a separate issue, the surface here that I'm working on is actually, I've put a piece of glass underneath all this just to protect the microscope from any of these droplets of nitric acid. Okay, let's have a see if anything's happened here. So you might be able to quite visibly see the blue color of the nitric acid there as it's dissolved the copper underneath. Oops, let's move that back into view. As it's dissolved the copper underneath the gold, and you can see where the vias were. So there's 3 vias in the pad. You can see that's actually been an entry point, and the gold is kind of flaked away around where the acid could get access to the copper like that. So let me just quickly do this, and then we'll give this another scrape. And once again, you can see there, unlikely that the gold from this will end up as a foil. I think you'd be pretty much looking at very fine, as you can see there, fine, almost a black powder, which is your gold if you're processing that. I suspect we're going to see the same with this one. As soon as I can also see it's gone quite blue from the reaction, I think we will find, yeah, very fine gold flakes. So once again, you'd probably find that you end up with powder when you process those, not nice foils. Looking at this one here, my gut feel is that you would actually end up with foils here. I might zoom out a bit. This is a bit bigger than the last stuff. Oops, that was about, yeah, we'll look at it about there. But whether I will be able to peel this as a foil using these tools, I'm not sure. Let's see if I can get any peeling happening. Oh yeah, okay, so if you look up there, it does look like it might actually peel like a foil. So you see the behavior is a little bit different from what we saw with the previous items. You can actually see that I'm peeling it off as a piece of foil. You do it in this way. Oops, it's very difficult to manipulate these very small things. Yeah, so so this probably is technically a hard gold plating, but it's a very thin hard gold plating. Now, if we move on to the RAM, I don't think I'm going to have any effect at all. What I'll do is I'll just turn it around so I can hold it with the left hand and scrape with the right. Let's get that back into view, like there. Let me just hold that down and give it a bit of a scrape. I don't think anything's going to happen. No, there's nothing to see here really. The gold is just so thick that what will end up happening is if I left this long enough, is the nitric acid would eat away the copper underneath the gold, and then the gold would show up as a foil. But because the acid can't get access to the copper through the gold, it has to go around. It's a much slower process, which is why this is the gold we're really
you know, if we're chasing gold-plated copper pads, this is the stuff we want to look at, or the stuff we want to pay money for, basically. So yeah, I hope this video has been enlightening to some of you. It shows you a relatively easy way to check the thickness of gold plating, especially if you're going to be paying for any quantity of material. And yeah, I hope this has been valuable to some of you out there. As always, good luck with your recovery and refining, and always be safe. Cool. Catch you guys later.